back when I was at UCF, I was part of a group writing a common final exam for calculus. Like all the calculus classes were taking the same final. And David Rollins submitted a question just like this for the final. And I said, "Really, David, you're going to put a mean value theorem on the final?" And he said, "Yeah, that I call that the A maker." Like everybody's going to learn the rules of derivatives, right? Everybody's going to study really hard on implicit differentiation. Only the A students are going to make sure they know mean value theorem and squeeze theorem and all these more obscure theorems. I'm like, okay, I like that. So the A maker, like everybody's going to know the basic stuff. If you want to get an A, you know everything. So we just did some mean value problems. And I thought, I wrote your midterm yesterday. And I thought, I'd already done an example like this. And I've looked through everything and I can't find it. So I thought, you know what? I'll do it in this Zoom meeting. Like, I'm telling you now, you got a problem just like this on the midterm. Just like this. Well, basically the same problem. This is what we call the A maker. Like I'm going to show you how to do it, but only the people that actually watch this whole video and are paying attention are going to know how to do it. They're going to come to the midterm and be like, "Oh, what is that?" The ones that just let this play in the background while they scroll on Reddit, we'll get them. Okay. So here's our setup. You pass a cop. Maybe he clocks you. I don't know. Maybe you're going 20 miles an hour. Doesn't matter. He radios ahead to another cop that's 30 miles down the road. Says, this guy passed me at noon. You keep an eye out for him. You pass another cop at 12:25, 25 minutes later. So you've gone 30 miles in 25 minutes. That's the key. They can charge you for speeding, even though this guy might not see you speeding. And when you pass the other cop, maybe you're only going 40 miles an hour. So neither one sees you speed. They can still charge you for speeding, and they can use the mean value theorem to prove you were speeding. So here's how we're going to do it. First, let's go maybe x of t be your position function. First, x is continuous and differentiable on this interval that we care about. Why? Because x is always continuous and differentiable, your position function. Unless if you throw a rock off a building and it hits the ground and comes to a sudden stop, then you would have you might have oops, and you would have a cusp and you wouldn't be differentiable at that point. We don't have that here. We've got a nice smooth position function. So we're continuous and differentiable on the interval. So mean value theorem applies. We have to say that to make sure we're allowed to use mean value theorem. Mean value theorem says that your average rate of change. Well, what's our rate of change here? Velocity. V of t is the derivative of position, and average velocity, my average speed, because we're moving in one direction, would just be change in position over change in time. So how far do we go? We went 30 miles. Now I want to be in miles per hour, so I'm going to have to do a little work here over my time in hours. So I did 25 minutes was my time. I need to convert that to hours. That'll be 25 out of 60 hours. So let's get our calculator out here. Let's turn that into a decimal. 25 out of 60. So point, like, sure, I could turn that into an improper, or into, I could reduce the fraction and just deal with fractions, but whatever. 0.42 hours. So 0.42. So what's my average velocity? It's about 30 divided by 0.42. My average speed is 71 miles an hour. And of course, I could have just done 30 divided by, and then in parentheses, 25 out of 60. See, that was an approximation. So it was really 72. Like, that's exact. So 72 miles per hour. Either way, it's above 50. That's really all I cared about. Mean value theorem says that if average rate of change, average velocity is 72 miles per hour, then there exists, so let's say here, by mean value theorem, I have to say that somewhere, there exists some C, some time C in the interval 12 to 1225, such that x prime, the derivative, also known as the velocity, oh, these are at C, equals 72 miles per hour. There's no way we can average 72 miles an hour without ever hitting it. That's what mean value theorem says. It's impossible to have an average speed of 72 miles an hour and without ever hitting it. And like we know from common sense, you if they the first cop, if this guy saw you going 20 miles an hour and the other guy saw you going 40 miles an hour, you must at some point been going a lot faster than that to bring your average up to 72. Doesn't matter. 72 is speeding. They can prove you were going faster than 50. So this would be a complete solution. So we got to say the position function is continuous and differentiable on the interval. We find our average rate of change, or average velocity. We're going to convert those minutes into some fractional hours. We're going to get an average speed bigger than the posted speed limit. So therefore, we'll say, by the mean value theorem, there must exist some time when you were speeding. And they can give you a ticket. This is like real world. They can do this. And it all comes down to mean value theorem. There's literally the same question with different numbers going to be on your midterm. I would know how to do it.